Okay, guys, we're going to work through this practice test. So the first question is about determining whether a relation is not a function. Guys, be so careful on the test tomorrow to make sure you read the words correctly. Because if you read which one is a function and you check the very first one and it is a function and you check that one off without checking the others, you're going to get this one wrong. So we're looking for the one that's not a function, meaning 3 of these will be functions. One of the easiest way to check if it's a function, my x values are -2, 2, 1, and 6. If I don't have a repeated x value, then that means each x value can only go to one y value, because -2 only matches with 3, +2 only maps with -3, 1 only maps with 5, and 6 only maps with -3. So A is a function. If I look at B, my x values are 0, 2, -2, and 3. Again, all of those are different, so that one has to be a function. If I look at C, I have -3, -4, -3 again, and +4. So here I'm thinking most likely it's going to not be a function, but I have to double check. -3 here is partnered with +2. -3 here is partnered with +3. So that's one single x value, -3, mapping to 2 different y values, +2 and +3. So this one is not a function, which means, since we're looking for the one that's not a function, that one's our answer. And if you wanted to double check, D, my x values are 1, 2, 3, and -1. Again, all different, so that one is going to be a function. If we look at question 2, it says which of these makes the relation a function. So again, I want different x values. I have 5, 3, 1, and something else. So basically, I don't want 5, 3, or 1. Well, that means it can't be H, because then I would have 5 twice. It can't be 3, or I would have 3 twice. It can, however, be F, because that is -1. -1 is not the same thing as +1. I don't already have -1 as one of my x values, so F would be the correct answer there. Now, if we move on to the sequence, now remember when writing a sequence, you can think about putting it in a table and just numbering the terms in the sequence, 1, 2, 3, 4. And then we can see the pattern. These are increasing by 8. So I know my equation is going to look like 8 times the number. So really, since this is multiple choice, we're looking for 8 times n. T equals 8 times n. And look, this one is +8, -8. There's not even an 8 in this one. So really, that leaves me with only one possibility. Now, if we were given more than one with 8 times n, then what you're looking for is, if I simply multiplied 1 times 8, that would give me 8, and I want 20, so I need to add an additional 12. Same thing if I picked any other value. If I did 8 times 2, that's 16, so to get 28, I'd have to also add 12. So D is the correct answer there. For number 4, finding the 11th term in the sequence. Now, the long way of doing this would be saying, okay, I'm adding 15 each time, and so add 15 plus 15 plus another 15 plus another 15. The shorter way, again, is to write a rule. So if I think about these as being the first, second, third, fourth terms in the sequence, I know my pattern is increasing by 15, so my term is going to equal 15 times the number. But 1 times 15 is not 1, 2 times 15 is not 16, 3 times 15 is not 31. So you have to figure out what else you have to do. Well, 1 times 15 is 15, which means to get back to 1 I have to subtract 14. And now, once I get that equation, now I can plug in the 11th term means my n value is going to be 11. So I get 15 times 11 minus 14. And if I do 15 times 11, that gives me 165. And if I subtract 14 from that, that gives me 151. So F 151 is our correct solution here. Moving on to number 5, it says which set of ordered pairs can be used to graph y equals negative 2x minus 1. Remember, if an ordered pair can graph that, that means it has to be a solution to the equation. In other words, this is simply a matter of plugging in the values and seeing if they work. So let's look at option A. Our first point is negative 5, 9. So that means the y value, so plugging into this equation, y equals negative 2x minus 1, I get y, which is 9, equals negative 2 times x, which is negative 5, minus 1. So negative 2 times negative 5 is 10, and 10 minus 1 is 9. So my first point checks out. So that one's good. I also have that exact same point on D, so that one's good. Now, let's move on to another value then. So since I know the first one's okay there, let's plug in the second one. So my next point is 1, negative 3. So my y value is negative 3 equals negative 2 times the x value, which is 1 minus 1. So let's see, negative 2 times 1 is negative 2. And if I subtract 1 from that, I get negative 3. So that one also works out. Now, that leaves me with one more to check for A to see if that's correct, which is 4, 9. So my y value again is going to be 9. My x value is going to be negative 5. And we get, oh, excuse me, my x value is 4, looking at the wrong point. So I get negative 8 minus 1, which is negative 9, not positive 9. So this one's not part of it. So if we look, when x is 4, y is negative 9, not positive 9. So A is not our option. But look, here I've got 4, negative 9. I know that C is not an option because when x is 4, y is negative 9, not negative 3. So C is automatically out. And then that leaves me with, I'm going to guess probably D is right because I know that this one's right and I know this one's right. So that leaves me with just one to check. I just need to check negative 2, 3. So again, I'm going to plug into my equation. Y equals negative 2x minus 1. So y would be 3 equals negative 2 times x, which is negative 2, minus 1. Negative 2 times negative 2 is 4, and 4 minus 1 is 3. So this one also works out. So D is the correct answer. Alright, number 6 says which of the following is not a solution? Again, pay attention to words. We want to make sure that this one is not, meaning that 3 out of these 4 points are going to solve for x plus 3y equals 6. Only one of them will not work. So, plugging in, we'll start with the first one. So 4 times x, which is negative 3, plus 3 times y, which is 6, should equal 6. So just plugging that first point f in. So I get negative 12 plus 18 equals 6. And negative 12 plus positive and 18 does in fact equal 6. So that one is a solution. But remember, I'm looking for the one that's not a solution, so I have to move on to the next one. Now for the next one, I have the x value is 0, so 4 times 0 plus 3 times, and y is 2, should equal 6. And if I work this one out, I get 4 times 0 is 0, plus 3 times 2 is 6, and 0 plus 6 does in fact equal 6. So that one's also a solution. So I'm looking for the one that's not, so I have to move on to the next one. For the next one, I have 4 times x, which is 1. So 4 times 1 plus 3 times y, which is negative 2, should equal 6. 4 times 1 is 4. 3 times negative 2 is negative 6. So I end up with 4 minus 6 equals 6, which is not true. So H is not a solution. And then it's always a good idea, if you have a little extra time, to double check. There's only one left to try. So if I've got a little extra time, I want to try it just to make sure I didn't accidentally goof up. So 4 times 3 plus 3 times negative 2 should equal 6. And so I get 12, and then minus 6 does in fact equal 6. So that one also works out. So H is definitely the only one that's not a solution. All right, and then the last thing we have is a rate of change problem. And remember, rate of change, slope, they're all the same thing. It's the change in the y values divided by the change in the x values. So here my y value is increasing by 5. My x value is increasing by 1. So 60 minus 65 minus 60 over 11 minus 10 gives me 5 over 1. So my rate of change is 5. Alright, so I'm going to pull up another slide and we'll look at some more examples, some more problems off the practice. Question number 8, we're looking at a direct variation problem. It says the cost of apples varies directly with the number of pounds bought, which means that the cost is equal to some constant times the number of pounds. So it says if 3 pounds cost $3.90, then we'll find the cost of 6 pounds. So all this is saying is, okay, 3 pounds, so 3 times whatever that constant is would equal $3.90. So if I want to find out what the constant is, then I divide by 3, and $3.90 divided by 3 gives me 130, or 1.3. So my constant of variation is 1.3. And so now if I have 6 pounds instead, then I just do that 1.3 times 6, which gives me 7.8, or $7.80 would be the cost of 6 pounds. So if you know it's direct variation, you can divide to find what the constant of variation is, the y value, which in this case would be the cost divided by the x value, gives you your constant, and then you multiply that times your x value to get your new y value. Alright, let's see. Number 9 is just a very simple slope question. We just have 2 points. We've only done about 1 billion of these. So the slope of the line through these 2 points. So remember your equation for slope of a line, y2 minus y1 over x2 minus x1. So if I use negative 5 minus 1, then that means on bottom I should have 2 minus negative 3, which I'm just going to rewrite as 2 plus 3. So negative 5 minus 1 gives me negative 6, and 2 plus 3 gives me 5. So negative 6/5, or B, would be the slope of that line. Now, for the slope of the line, y equals negative 3, remember, if the equation is y equals something, it's parallel to the x-axis, and the x-axis is a line with 0 slope. It's horizontal. Whereas if the line was an x equals line, then it'd be parallel to the y-axis, which is straight up and down, which is an undefined. So this would be a 0 slope. X equals something is an undefined slope. Or you can always sketch a graph. If I looked at a graph, y equals negative 3 is down 3. Anything on this line is y equals negative 3, and you can clearly see that is a 0 slope line. It doesn't go up or down any. All right, and then that leaves us with college tuition and fees in the year 2007, averaged $5,836 a year at a four-year public institution compared to $3,510 in 2000. What was the rate of change? So for this, the change in the Y values is the change in price, 5,836 minus 3,510 over the change in years, which would be 2007 minus 2000. So 5,836 minus 3,510 gives me 2,326, and then 2007 divided, or minus 2,000, of course, gives us 7. And then to find the rate of change, we would just divide that out. So divide by 7, we get 332.2857 something or other. It doesn't really matter because it's money, which means nothing past the 100th place has any meaning. So I'm going to round to the 100th place, which makes it 332.29 cents. So $332.29 per year. So B is the correct answer for this one. All right, now I'm going to try and do this again because I already worked 12, 13, and 14, but forgot to resume my recording. So yay, I get to do it twice. All right, so number 12. This one is worded kind of confusing, but here's what you need to pay attention to. Y varies directly as the number of inches x. So the number of feet y. So y varies directly as x means y equals k times x. Now, then they go on to tell us, write an equation using the fact that there are 12 inches in a foot. That gives us a specific x. X is the number of inches, so this is telling us x is 12 and y is a foot, which is 1. So when y is 1, x is 12. So if I want to find out what my constant of variation is, all I have to do is divide through by 12. So I get k equals 1/12, which means my direct variation equation, since direct variation always means y equals k times x, where k is a number, my direct variation equation is going to be y equals 1/12 times x, which would be j, 1/12 times x. Be careful, a lot of you will be tempted to put this one because you know that there are 12 inches in a foot, but the problem here is this is saying that you take the number of inches you have and multiply it by 12 to find out how many feet. In other words, 3 inches would equal 36 feet. Obviously, that's not true. So you have to pay attention to the fact that x is representing inches here and y is feet, not the reverse. All right, number 13 says state the slope and y-intercept for the graph of y equals 3. Remember, we just talked about this. A y equals line is parallel to the x-axis. The x-axis is a horizontal line, which means it has a 0 slope. The y-intercept is where it crosses the y-axis. Well, so what's the y value when x is 0? Well, here it tells us our y value is 3. When is y 3? All the time. So if x is 0, guess what y is? That's right, it's 3. So our y-intercept is definitely 3. So A, slope is 0, y-intercept is 3. Now, if I'd had a graph like x equals 3, then my slope would be undefined because it would be a vertical line. X equals is a line that's vertical, horizontal, it's parallel, to the y-axis. So it has an undefined slope, and its y-intercept would be non-existent. So that option isn't even on here. Okay, if it had a slope that's undefined, its y-intercept wouldn't be non-existent there. All right, looking at number 14, here we're going to write an equation in slope-intercept form. So this is basically what we did in section 8.8. So for this, pick 2 points any two you want. I'm just going to use the first two. So start with your slope. So y2 minus y1. Now I'm going to do 7 minus 1, which means my x2 needs to be negative 6. So I should have negative 6 minus 3 on the bottom. Now again, I could have set this up 1 minus 7, and then it'd be negative 3 plus 6. I'll get the same thing either way. Just make sure that if I'm doing this value minus this one, then I need to do this value minus that one. And remember to make sure your y values are on top and your x's are on bottom. So I get 6 over negative 9, which simplifies to negative 2/3. So there's my slope. Then I need to find my y-intercept, which you can either do by putting it in point slope form, or you can just pick an x and y value. Now if I'm looking at these and I want to pick an x and y value, my favorite ones to use right there are those because they're nice and positive. So if I'd use those, y equals m, negative 2/3, times x, which is 3, plus b. Negative 2/3 times 3 is negative 2. So I get 1 equals negative 2 plus b. So I have to add 2 to both sides, and I'd get 3 equals b. So my y-intercept is 3, my slope is negative 2/3, which gives me g, negative 2/3 x plus 3. Number 15 is pretty straightforward. Here they simply tell you the slope is negative 4, the y-intercept is negative 7. So slope-intercept form, y equals the slope, negative 4, plus the y-intercept, which is a negative here, so it'll be minus. So obviously B is our correct answer there. Alright, question number 16, we're looking for the equation and slope-intercept form of a line passing through the points negative 2, negative 1, and negative 1, 4. So the first thing we're going to do is find the slope between those 2 points. So we're going to do y2 minus y1, so I'm going to do 4 minus negative 1, which I could just rewrite as 4 plus 1. And then I'm going to do negative 1 minus negative 2, which of course is negative 1 plus 2. So 4 plus 1 gives me 5, and negative 1 plus 2 gives me 1. So my slope is 5 over 1, which is 5. So I know it has a slope of 5, which really already eliminates f and g, so only h and j are even possibilities. Then to find my equation, I'm just going to do y equals 5x plus b. I'm going to replace my x and y with, I'll just pick negative 2 and negative 1. So my y value, negative 1, equals my x value, negative 2, times my slope, 5, plus b, and solve for b. So that gives me negative 1 equals negative 10 plus b. So if I add 10 to both sides, I get that b is equal to 9, which means my equation is y equals 5x plus 9. So H is the correct answer. Alright, the final one here, we have to graph y equals negative 2x plus 3. I'm going to start with my y-intercept. That's going to be 3 points above my origin, so that gives me this first point here. And then since my slope is negative 2, remember that means negative 2 over 1. Anytime you have a whole number, it's over 1. So I'm going to rise negative 2, so I'm going to go down 1, 2, and then to the right, positive 1. And that gives me the second point that's on my line. And if I graph those 2 points, and then I just use my line tool to connect the two, and I have this line right here. Alright, let's move on to the next page. Alright, so picking up with number 18, here we're going to graph a line that has a slope of 3/2 and a y-intercept of negative 1. So I'm going to start with my y-intercept, negative 1. That's where my graph starts. So I go 1 below, and that gives me my first point. And then my slope is 3 over 2, so I'm going to rise 1, 2, 3 units, and run 1, 2, and that gives me a second point on my line. And then keep in mind I can also do a rise of -3 and a run of -2, because a negative divided by negative is also positive. So if I rise -3 and run -2, then that gives me this point right here. So I can connect those points, and that will give me this line right here. Now, the equation of a line that has a slope of -4 and a y-intercept of 2, that's very straightforward. You just have your standard form, y equals mx plus b. So we just replace m with our slope, -4. So I get y equals -4x plus b, the y-intercept, which is +2, so +2, and that gives me my equation, y equals -4x plus 2. If we go on to the next one, equation and slope-intercept form of a line passing through the points 2, 5, and 3, 7. Once again, I'll need to start with the slope here. So I'm going to do the change in the y values. So I'll do 7 minus 5. So that's the second y value minus the first. So that means I need to do 3 minus 2, the second x value minus the first, which gives me 2 over 1, which gives me a slope of 2. So that tells me my equation starts out y equals 2x. But then I need to find out what I'm adding to that. So if I do y equals 2x plus b, and I replace y and x with 5 and 2, and then I have 5 equals 2 times 2 plus b. So that means 5 equals 4 plus b, which means b has to be 1 if I subtract 4 from each side. So if my b value equals 1 and my slope equals 2, then my equation is y equals 2x plus the y-intercept 1. The slope of the line x equals 4. Remember, if the line is x equals 4, then that tells me that it is parallel to the y-axis. The y-axis is up and down, so this is a vertical line, meaning its slope is undefined, which you can either write the word undefined or you can write the little 0 with the slash through it, which just means the empty set. So the line y equals 4, well, if x equals 4 is this vertical line, then that means y equals 4 is parallel to the x-axis, which makes it horizontal. And again, you should just have that memorized. X equals something is parallel to y, which is a vertical line. And y equals something is parallel to x, which is a horizontal line. Write the equation of the line that passes through 2, 3, and has no slope. Alright, if it has no slope, that means it looks like y equals 0x plus b. Now, if I want to plug in these values, I get 3 equals 0 times 2 plus b. So 0 times 2 is just 0, so I get b equals 3. So y equals 0x plus 3, which just simplifies down to y equals 3, because all you have is the y-intercept. There is no slope, which means the x term goes away completely, which is what we would expect because we just talked about y equals 4 is a horizontal line. So obviously that's no slope, so a line with no slope is always going to look like y equals something, and since the y value in this is 3, then it would have to be y equals 3. Alright, so just 2 questions left. Now, as you can see from these are both special cases. If we wanted to find the equation passing through 7, 4, and 7, 6, if we started with just our slope-intercept form, we'd have y2 minus y1, so let's say 6 minus 4, over x2 minus x1, which is 7 minus 7, which gives me 2 over 0, which is undefined. If it's undefined, that means it's a vertical line parallel to y, which means it's x equals something. And if we look at our x values, x here is 7, x here is 7, so the equation is going to be x equals 7. So that's all you need to do there, is just realize that, hey, if it has an undefined slope, it's going to be x equal to some value, and clearly that value is whatever value x consistently is in those 2 points. The opposite case, here we have number 25. Here, if I did my y values, y2 minus y1, I end up with -3 minus -3, which is -3 plus 3. And then I end up with 5 minus -1, which I can change to 5 plus 1. So that gives me 0 over 6, which of course equals 0. So this has a 0 slope. If it has a 0 slope, then it's going to be a y equals line. And since y here equals -3 and here equals -3, then the line is clearly y equals -3. Or since this one actually has a slope, granted it's a 0 slope, but since it actually has that, you can still plug into the y equals mx plus b format. Just understand that the mx part's going to go away because 0 times anything is 0. So you just end up with y equals b. And so if my y value here, pick 5, -3, so I get -3 equals 0 times 5 plus b, then you just end up with -3 equals b. So since y equals b, y equals -3 is your solution. All right, so those are all the questions on the practice test. Make sure you study tonight. Look back over the practice. If you want a chance at getting the bonus right, don't forget to do the IXL Level K S19. It's not for a grade, so just do enough until you kind of feel like you maybe understand what you're doing on them. It's just writing equations for lines using parallel and perpendicular lines. So it just has to deal with what parallel lines, what do the slopes of parallel lines look like, and what do the slopes of perpendicular lines look like. So review that if you would like. Test is tomorrow, and I will see you then.